In this video, we're going to use definite integrals to compute the area of a region bounded by multiple curves. So in this example, we're going to find the area of the region bounded by four curves: y equals sine of x, y equals cosine of x equals 0, and x equals pi over 2. So the first thing we always need to do is sketch the region. So here's my x and y axes, and now the curve x equals 0, that's just the y-axis. And then the curve x equals pi over 2 is just the vertical line x equals pi over 2. Sine of x, y equals sine of x, looks like that. And then y equals cosine of x. Y equals cosine of x looks like this one. All right, so it looks like when we compute the area of the entire region bounded by all four curves, we're actually computing the area of two regions. The area of the first region I'll call A1, the area of the second region I'll call A2. We're adding those two together. Now, notice that if we draw a representative rectangle, just pick a representative xi in the first region, then a representative rectangle looks like that, and it always has width delta x. And the height of that particular rectangle is going to be the y-coordinate on the cosine curve minus the y-coordinate on the sine curve. So it's cosine of xi minus sine of xi. That's the height of that rectangle. But if I pick an xj in the other region and get a rectangle over there, so that the width is still going to be delta x because our subintervals always have the same width, but the height of that rectangle is slightly different. It's the y-coordinate on the sine curve minus the y-coordinate on the cosine curve. So it's sine of xj minus cosine of xj. So what we need to do is compute the different areas using different definite integrals and then just add them together. So we need to figure out where the first one stops and the second one starts, right? So we need that point of intersection. Well, that point of intersection is where the cosine of x is equal to the sine of x, and it's between 0 and pi over 2. That just has to be x equals pi over 4. So the point of intersection is pi over 4. That means we're going to do the first area is going to be the integral from 0 to pi over 4. The second area is going to be the integral from pi over 4 up to pi over 2. So let's set it up. So the area we're looking for is going to be area 1 plus area 2. And now area 1, as we said, is the integral from 0 to pi over 4 of cosine of x minus sine of x times dx. And then the second one is the integral from pi over 4 up to pi over 2 of the sine of x minus the cosine of x dx. All right, so now we just need antiderivatives and then evaluate those. So the antiderivative of the cosine is sine. The antiderivative of sine of x is negative cosine of x. And we're going to evaluate that from 0 to pi over 4. And then the second one, the antiderivative of sine of x is negative cosine of x. The antiderivative of cosine of x is sine of x. And that one we're evaluating from pi over 4 to pi over 2. All right, so now we're going to start plugging in. So the first one, sine of pi over 4 is root 2 over 2. And then we're adding the cosine of pi over 4, which is root 2 over 2. We have to subtract the sine of 0 plus the cosine of 0. So we're subtracting 0 plus 1. And then in the second definite integral, we're taking negative cosine of pi over 2, which is just negative 0, which is 0, minus the sine of pi over 2, which is 1. And then we're subtracting a negative cosine of pi over 4, which is negative root 2 over 2, minus the sine of pi over 4, which is root 2 over 2. All right, so when I add together all of these fractions, I get 2 times root 2 minus 2, and that's square units. So remember, always sketch the region and visualize representative rectangles. If your curves cross, you may have to split it up into multiple definite integrals. You always want your area to be positive. If you guess which curve is on top and which one is on bottom, and you guess incorrectly and integrate, you'll get a negative answer, and that's never correct. So if you get a negative answer, then go back, sketch the region, figure out which curve is above which curve. And if you have a point of intersection and they cross, split it up. All right. So we will do more examples of definite integrals, and we will see some applications. All right. I'll see you in some later video.